Broadcast is now starting. All attendees are in listen-only mode.
Good evening, ladies and gentlemen. Welcome to our event for November for Business Change, SPA, and Quality SGs. Our speaker today is Tom Gilb. In the second part of Managility, please let's welcome Tom. Tom, please carry on.
So here's the first slide from part one, and there's the QR for the slides, and there's a tiny .cc Managility slides if you want to pick them up sooner or later. I'm going to skip the first part that we have a video of published, or you can, those who haven't heard it before can review the slides, and I'm going to start on slide 27, which gives kind of an overview. Here we have IT Agile, Scrum and all that stuff. Here we have all forms of Enterprise Agile, of which I have one from Mike Kottemeyer linked in there. And what I'm going to do is I'm going to add some very specific tools to make it more powerful and more appropriate for large scale and for management level agility. And the three things I'm going to add are the idea that the values, often called objectives, requirements, qualities, are always quantified, and they are the main thing giving us direction. The second part is that the strategies, often called architecture, design, solutions, in order to reach the values, we're also going to engineer them and look at quantify how good they are in many dimensions of value and cost. So there's an engineering approach there. The third part is getting feedback at every delivery step on the degree of increment we have towards our values and the degree of consumption of resources, so that we can adjust the architecture, for example, in the middle of the incremental delivery. So this is all quantified and multidimensional. And finally, there is a quality control, which is not testing, but it is it's a way of quantifying how good are my requirements, what is the quality of my architecture, and we can quantify how good they are and throw away the specifications that are substandard. So that's an overview, and part two is really the technical details. Part one was really sort of a top management overview, looking at different classes of enterprise agility, and so this is our version in detail. So I've summarized everything I want to say, of course, in about 10 principles. And I'm going to go through these principles one by one, and that's the content of the talk, if you like. It's summarized in these principles. So principle number one is the idea that everything in an agile enterprise, all the organizational components, the products, the projects, etc., can, in my opinion, all be managed by managing the top 10 most critical objectives, or stakeholder values is another way of naming them. And I believe that the whole reason for being for these organizational units or projects or systems is to deliver a certain level of value to stakeholders. And most of these values will be things like qualities like security, privacy, user-friendliness, and things like that. And my belief is that we can do better than just write nice sounding words to preserve and improve human life. We can take things like that as a starting point, as an ambition level, and we can quantify these things so that we understand very clearly exactly how much we're going to preserve human life, how much we're going to improve human life, and by the way, what is a human life? So there are a lot of ambiguous words there that need definition. And if we don't have that definition, everybody will make their own independent and different definition, and we'll all be fighting each other because of our misunderstandings. So here is an example of taking this core purpose of the Merck Corporation and defining a scale of measure, okay, and then defining points on that scale, benchmarks, constraints, the worst acceptable case, and the actual ambition levels we want to reach. So the big exercise that people don't do, but should, in my opinion, always do, is to define a scale of measure. So it's like if we just kept on saying, I've got a really fast car, that's nice, but in miles per hour, how fast is it? Okay, in miles per hour, and that's the scale, it's 360 miles per hour. Oh, wow, that's really fast. But maybe I could have said it's 100 miles per hour and said, well, that's pretty fast, etc. So it's just not good enough to have degrees of things that need to be improved and to not have a scale of measure and not be able to say how bad we are today and how the minimum of what we have to be in the future and how good we have to be, for example, in 2022 and 2024 in different areas. So that's this first idea. Here's a little bit more detail on it, still using this illustration of one value amongst many. This is our scale. This is a graphical idea of the scale. And then on the scale, we have various things, for example, benchmarks, which are systems analysis and telling us where we are. Constraints, which are saying this is the minimum you have to have, the worst acceptable case, before you can release or deliver or expect to get paid for it. And finally, one or more goals in time and space. These are our success levels, also known as targets. Now, when we use the planning language, which is in really all these slides and all the books I'm going to refer to, we have a number of ideas that come out, and I'm going to go through them in a little bit more detail. First, we forbid fuzzy objectives, nice sounding words. Then we say, okay, let's get clear. And the king of clarity is the scale of measure. That's this one here, for example. And but within the scale, there are a number of ideas or tools. For example, there are things like parameters. So estimated better days for a defined life form. Okay, that's a parameter. I now have a general term in my scale, and I can decide to select, for example, that the life form is any biological form, not including plants. I could also say it was human beings or something like that. But I can define a number of different life forms, and I can then have plans for different life forms. So that's basically the idea of a parameter or scale parameter. The other idea is that these definitions are reusable. That is, we have one and only one master definition. And whenever we want to cite it or refer to it, say in a PowerPoint presentation, we refer to it by its name or name tag. And that goes to the master definition, of which there is only one. And we're spared the pain, really, of having everybody who makes a set of slides writing out the requirement in a different language with different ideas at different levels. Okay, the main idea is we're going to define the values once. We're going to define them very well, and then we will forever reuse the good definitions we have. So there's a concept of master specification and reusable. This permits many things, not least we're not jumping around all over the place with different opinions about what the requirements are. Quantification is not the same as measurement. It is we're putting a number on things, and the main purpose of putting a number on things is actually to make it clearer. See, enhanced says one thing, but 62.5 says something much clearer. So we're using quantification primarily as a way of clarifying an idea so that people can communicate about it and agree or disagree that the number is the right number. It's difficult to disagree about enhanced, but it's a lot easier to disagree about 62.5 when you think it ought to be 80. We also have the concept of benchmarks built in. Benchmarks are a series of things. Largely they are, how is the system now? How are your competitor systems? How do you expect your competitor systems to look in the future? And things like that. But they are, so they're not requirements, but they're information about the coming requirements. And the distance between the benchmark and any of these future requirements is the degree of improvement. So the degree of improvement goes from a benchmark to a constraint and or to a target. So we have a mechanism for defining enhanced, increased, improved, the management bullshit words, which is very specific, but it starts with you have to have a benchmark to define the distance between two levels of the same quality. Constraint levels, many people, even when they do quantify, they just have one number, they're like the goal. We actually have many constraint numbers and many targets for different times and places and situations and dates. The primary idea of the constraint level is say, this is a minimum. And you can then say, below this, we cannot release the product, or below this, we will not meet contract, or below this, we cannot beat the competitor. It's a minimum. But the minimum is not the same as what I call a success level, which is the targets, for example, a goal. Okay, a goal represents a statement of how good we need to be successful. This constraint might just represent where the competitor is, and anything less than that would then represent failure or worse than the competitor, and anything equal to or better, well, that's good, but we intend to be so much better than the competitor, and that we state in the goal. The success levels, also called targets, also called goals, but they define successful enough. They also define now you can stop using resources on improving this because we've got enough and more has not been asked for. Okay, but we can think of them as success levels. We can also have short-term increments, like what's going to happen next week, next month, next year, but we can at the same time put in numbers which are perhaps visionary, in other words, 5, 10, 15 years ahead, like the United Nations sustainability goals are, for example, 15 years ahead, although they're not very well stated is another thing. Okay, so in other words, this one thing has a lot of technology in it, and I suggest that these things are necessary for Enterprise Agile, for taking things very seriously. You don't just say we need to improve life, but we need to pin it down so nobody can misunderstand. Here's one of my heroes, and those who don't know him should get to know him, Ray Dalio. He's got a book, a little bit late, but it's coming out soon. And he publishes a sort of a weekly blog. He believes in principles like I do, so he has principle of the day, and this particular principle said that we really need to have an accurate understanding of reality, which is the essential foundation for any good outcome, and that, of course, is my benchmark. Thank you, Ray. But Ray's an amazing guy at the enterprise level, so get his book, sign up for his free blog, and have fun. Principle number 2, clarity. Now, indirectly, I've been talking about clarity, but I've been talking about the clarity of the values and the goals and very specific techniques here. So here's an example from the National Health Service of something which is unclear. One of their goals is to have access to medical records which will enable better care. Now, access. Who is going to get access? Under what conditions will they get access? How much access of the whole record will they get? And what in fact are medical records? I mean, do they include the name and address? So there's, ambiguous, 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 and then will enable, that's what I call a link word, better care. So better care is actually the value, but we haven't said what kind of care, to whom, or when, or why, or how much better, or when. So this is a totally undefined critical value. And largely the NHS doesn't go much deeper than this. If you start looking for serious numbers and commitments, forget it. I've been through most of their annual plans, and there's the long-term plan. Take a look for yourself. So this is actually a strategy or design, which is vague and has many meanings, so it isn't pinned down well enough. And so this, you can see the strategy is unclear, okay? And then this is the goal, better care, but that's also unclear. Now, we have a project in Norway called Axon, which is the scandal of the year, and here's some detail about it. But it's of the same nature. It's the big health system for the country, but the Parliament in Norway and the government have already pinned this down and said, you guys are wasting an incredible amount of money and delivering nothing. They spent 8 years doing nothing and spent millions doing it. And then they have a plan to spend another 8 years and billions doing it, and they probably will totally fail. So but I believe it's because all the objectives I've seen are like this. And I tried to talk to these people about it, and they just say, we don't need that. It's good enough. And nobody in the government is yet insisting we're clearer. Well, now the government's decided they've had enough. Okay. So, but these are large, enterprise agile projects, and they need this is okay for, one man and a dog projects, but when you're doing a national health system of a country, you're at this. You need managility, you need management agility, and you need these techniques to just define what you're going to do and what you're going to spend all that money on and all that time. Here is more detail from the NHS. Now, if you take a look at this, you'll notice first thing is largely it's all text. You won't find any numbers about how good anything is going to be, number one. And notice these underlined and bold words: enable, support, makes best possible word. These are what I call link words. And I discovered that that's how people write things. I was working with an industrial corporation today, and all the 8,000 people in the organization, and all their management goals were written exactly like this. So this is, I guess, what they teach you at business school or something. But it's full of ambiguity, lack of clarity, and if you wanted to doom a project to make sure it couldn't possibly work, you would write things this way. If you want them to succeed, you're going to have to parse this vague management stuff. And here's a long list of all the things we need to deal with. Take a sample. I mean, for example, they say we're going to do A in order to achieve B, but there's no side effect analysis. Okay. In other words, we might achieve B, but we might destroy C, D, E, and F. And normal engineering takes a look for side effects. Those who don't look for side effects get failed projects. Okay. So there's no sign of anybody. They're thinking in one strategy and one dimension. They're not thinking in multiple dimensions, and therefore they're not doing side effect analysis. There's no information about risks and uncertainties here. It's just, we're going to do this, we're going to do that, we're going to do this. And there's not even a little footnote saying, here's a place where we've talked about the uncertainties. I think uncertainties and risks need to be baked into the specification, integrated into the master specification. Now, just for timing's sake, taken a sample, but if you want a thorough checklist of what we need to do when instead of this stuff, what, for example, the National Health Service does, and I hope somebody from them is listening, and I'll help them if they want help. It's a long list of doing things properly for large-scale systems. And here's a free book, 500 pages, Competitive Engineering, which defines in detail how you do all these things in case you don't know. yet, and I'm giving it to you for free. Isn't that nice of me? Okay. Here's a something I worked on once, Department of Works and Pensions. Again, when I asked people where are your goals, I got, you know, the usual nice set of words. Those who don't go to work are encouraged to have a go. And but for fun, I said, well, what's this all about? And I defined benefit dependency with a scale of measure, a past, a goal, etc., and began to analyze the stakeholders. If you want more information on this, I've got another free book I wrote this summer, Governeering. There's the link to it. And this goes into a lot of public sector. If in the public sector, in other words, Department of Works and Pensions, National Health Service, the military. I've taken a lot of examples and focused on how to make them better. This is from that book then. So, you know, you can't just wish for clarity. It's amazing, like the National Health people in Norway, when I showed them in detail what they could do and how unclear it was, they just said, we think we're clear enough. It's like, yes. That's like Trump saying, I think I won the election. I don't know, no evidence. They wouldn't even have a serious discussion about it. And you can't say smart either. I mean, again, at a small scale, having smart objectives, where M is for measurable and things like that, is probably a very good idea and going in the right direction. But we're talking about the large scale, long-term, complex systems like national health systems. So smart is a little bit too simple. And we might say that what I'm trying to show you is an advanced, large-scale version of smart. Okay. By the way, I have another couple books for you. Clear Communication. You'll have to pay a little bit for that, but if it's not worth 14 euro, you needn't bother. If you want a cheaper one, the plan analysis book I wrote this summer, it's free, and it goes into detail on how to analyze plans. You might like to start with that one. In a little bit into the quality assurance area, most people, when they say I'm in QA, they mean I'm in test, and I look for bugs in programs, and that's all I do. I think we have, at the large scale, we have to go a lot further. We have to be at the quality assurance level, including things like prevention of problems and defects in the organization and in the system, not just in the code. Okay, so a stitch in time saves 9. Okay, and we've got to move away from this incredible overemphasis on testing to something much smarter and, in fact, much cheaper. Here are some policies. For example, the quality assurance needs to be guided by the most important thing about any project or any section of the organization, what I call the top 10 critical numeric value objectives. Okay, in other words, the reason for any project can be summarized pretty well in 10 critical objectives, and the reason for any component in an organization can be the same. And these objectives will say how good we are right now in these 10 critical quality, if you like, value areas, and what our future improvement levels are planned to be. And then quality assurance should be making sure that we attain the 10 quality objectives, that we move towards our target. Now, that doesn't sound at all like finding bugs in code and fixing them. So it's time we learn what quality assurance really means, and it does not mean testing. Okay, I believe very strongly in delegation of power to the organization to find out what's wrong with the organization and what we can do to change our part of the organization by having better tools, better training, better time, better budget, whatever. So that the organization prevents bad stuff from happening. Here's a case study in my Power to the Programmers lecture, which is about delegation of Raytheon using that power using a thing called the defect prevention process and reducing the rework, 43% of everything for 1,000 people, and reducing it first very quickly and then a little bit more slowly, and over an 8-year period reducing it to 1/10. In other words, saving 400 people for productive work. That's the practical documented case study effect of these ideas. So take a look at them there. This is also reducing the bug density at the same time by about 3 to 1. And there's a case study of using this for product development at Ericsson for their base station products right there. This is an appropriate, this is pretty much focusing on IT and software. This focuses on the whole product, which is about 1/20th software and 19/20th various kinds of hardware. Okay? But another nice little free case study. There are some things that people have to do to say they're seriously using quality assurance. For example, can you track and trace a long-term improvement curve over several years? Okay, if you are, you're probably systematically working towards improving the quality. If you cannot do that, you're just throwing in ideas and methods, and then new management comes in and wipes out the old methods and puts in new methods. Well, you're not doing systematic quality assurance. Systematic quality assurance is year by year systematically improving quality aspects of the organization and the system. So if you can show a graph of where you're planning to go and where you've been and where you're going, you probably are doing systematic quality assurance. Otherwise, you're not. What about the chief technical officer level? Are they completely committed to the quantification of all critical objectives and qualities and values? Or are they still, as I experienced today, in the bullshit mode and permitting it at their own level and at all levels below them? Okay? I was talking to the chief technical officer of an organization today, and think we got him to buy in, we'll see, but really said that it's not good enough to have all this wishy-washy bullshit all over the place for your critical purposes. You have got to mandate that all critical factors are quantified. End of discussion. Okay, so here's an example of a set of top values for air pollution analysis in London. And all of these, you can't just say we're going to have good air quality. You have to quantify exactly what you mean so you can measure and track the change and specify improvements you want in the future. I guess the air quality is excellent in London these days for some strange reason. So, and we also need long-term sustained support, not just flavor of the month. We have a new method, and the manager who supported OKR at this organization left last year, so it sort of fell apart. You've got to have a multi-year sustained commitment to things that work, at least. If they don't work, dump them fast. Okay. What we also learned from the experiences at Raytheon, IBM, and other places is that improvement is a multi-year process. For example, at IBM, they over an about 2.5-year period for an organization of about 2,000 people in Minnesota, they had 2,167 different changes or improvements embedded in the organization. So it's not like there's one big silver bullet that saves everything. The grassroots people need to figure out the many small practical improvements, which on an everyday basis for 2,000 people make a difference to their work. This is, again, about, you want more information on the defect prevention process, use that link down there. That's almost nobody seems to know about this stuff. One of the largest adopters of my methods is Intel. Since 2000 approximately, they've trained and over 20,000 engineers in the methods. And here's a report for using the methods for requirements for their chips, and then using my quality control method, specification quality control. They mention that the use of all these things gives 233% higher productivity and 50 times better planning documents like requirements of design before release. And here's actually, let's see, we have the link to this. I hope, there it is, yeah. So if you want to read about it in detail, in practice, the use of these methods, there it is. But a simple example, the engineers hand in a 31-page requirement document, and then using specification quality control, they find 312 defects. These are things like an unclear word or term. And so Intel says, sorry, our quality standard before we hand this off to architecture for the chip is actually 50 times better. So you're 50 times worse. So try again. And they keep on trying and trying. And after about 5 iterations, they actually get 50 times better. And so they've prevented all of these defects in the requirements for getting into the architecture, not to mention the manufacture of millions of chips and spreading them all over the world. So that's a very smart organization. And that's what you have to be at the level of enterprise agility. Okay. They, of course, are using the my Evo agility methods there, just about everything. So number 3, the critical strategies. So we're into design and architecture now. We've moved away from we've moved away from just requirements and objectives. We need to again avoid having 3 nice sounding words like we're going to use really good security tactics, and define the strategies with far more detail, far more specifically, so that people install exactly the strategy we were thinking of and not their misunderstanding of the ambiguous strategy, and so that we can estimate based on case study and historical data of that exact strategy how good it is, what its side effects are, and what it's going to cost as a preliminary to even choosing or prioritizing that strategy. What we normally see is from these, like the NHS things I showed you, is people have named the strategy vaguely. They've not done any kind of estimation or point to it anywhere of the costs or benefits or side effects, and they just declare that this is going to be our strategy. And they've got no, this is like Trump declaring fake election with no evidence whatsoever. Most people think that's kind of silly, but apparently Mr. Trump doesn't. Okay, so don't be a Trump. Be a sensible, level-headed engineer. We really have to use engineering methods at the level of these very large organizations and systems. We have to engineer the national health system and almost all the large government systems. So now, again, it's having a clear set of critical attributes is the basis for selecting strategies and for judging them and prioritizing them, and then even deciding whether they measure up in practice as we're delivering them incrementally in an agile way. So again, here from National Health Service, words, link words, but not very, nothing very clear, everything ambiguous, and it's just not good enough. And yet, this is a state of play not only in the National Health Service, but probably most government institutions in most countries, and unfortunately in a lot of private companies. In the book I referred to earlier, as a second reference to it, Plan Analysis Free Copy, there are some disciplines for analyzing plans. For example, is it clear? Is it unambiguous? Can anybody misunderstand it? Is it complete, or is it missing detail which is significant, right? What are the connections between this strategy or this goal and everything else? What are we supporting? What is supporting us? Who is responsible? If we don't quantify the value, we can't really deal with critical variables. Okay, if the strategies haven't got an estimated impact on security, on usability and other things, then we haven't analyzed their impact, and we can't really select them and decide they're going to be there. But that's exactly what the National Health system is doing. It's selecting its strategies without any attempt to match them up. It's just the opinion of an unknown person, no responsibility, is deciding you're going to use certain strategies in their plan. And what are the NHSS objectives? There's another link there. And it's just not good enough that an unnamed, irresponsible person selects a vague strategy for a vague goal. This is not done. And somebody like Parliament or the Prime Minister needs to wake up and prohibit it and take responsibility for misuse here. Stakeholder, skip a little bit here, but another thing I find is wanting is systematic stakeholder mapping. I mean, how many critical stakeholders are there in the National Health Service or for the Ministry of Defense projects? And the answer is at least 50 and maybe 500 types of stakeholder, like I don't know, CT scanner nurses, okay? And they have their needs and they have their requirements. And I find that we're a little bit too locked into the idea of customers and users. Those are words straight out of the Agile Manifesto stuff. And customers and users is good, but what about the other 48 stakeholders, like the laws on privacy or health that apply? Okay, they have a voice too, and they have requirements. So long story short, I believe we need to buckle down for the large systems and systematically say we're going to start with stakeholder analysis, and we're going to keep on doing stakeholder analysis at all times because they'll pop up as things happen. Okay, and then from the stakeholders, we're going to derive their requirements, and we can't satisfy all their requirements, but we will satisfy the cost-effective necessary requirements for the scope of what we're going to do. And then we'll talk with them and say, you're not going to get the following things from us, but you will get the following things from us if and only if we have a big enough budget to do it or something like that. So a lot more stakeholder analysis stuff. Something I found is that these critical values, these top 10 things, they are the real reason for absolutely all projects I've ever encountered or could ever imagine. They're about keeping things not too bad and making them better. And so I think it's time we just didn't even call them requirement. We call them the critical objectives of the project, okay? And then we have to have a more rigorous specification. So here's the bullshit specification, which we simply call ambition level: drastically improve air quality in London to acceptable legal levels. Very nice as a starter, but you need all of this kind of specification, including a decent scale of measure and ideas of how we're going to measure it in practice and how bad it is here and there, different places for different types of gas, and the minimum levels and the success levels and in our dream stretch levels and things like that. And we need to, we need to capture, let's say, in simple terms, a whole page of data about every requirement or objective. Now we're capturing typically a few words. If you take a look at the examples I've given, and a few words is not enough. Principle number 4, and I take a look at my watch and realize I'm somehow running out of time, so I'm going to have to go a little bit faster, but what the heck. Is the simple idea that we have to, here's a strategy for NHS, but it also names at least 3 objectives it's going to support, okay? So this is a simple proof of multidimensional objectives are in place and that one strategy can support many objectives. But even if one strategy is just there to support one of the objectives, it likely has some impact, sometimes very negative impact, on several other critical things. And we can't afford to have one-dimensional thinking that we're going to do this in order to achieve this, and I don't care about the other stuff. We've got to systematically analyze potential side effects based on known data for use of such devices. And we've got to reject or down prioritize those strategies that have negative side effects that we can't really tolerate, and find some better ideas that just simply by design don't have those negative side effects. Here's a way of doing it. Let me introduce to you very quickly the impact estimation table. On our BCS courses, we usually spend a whole day just teaching this, and this is from actually a BCS course in London. But on the first day of the course, we identify the critical factors. This is for air pollution. We identify some cost ideas, and then we identify various bright ideas. That's the light bulb. These are known as strategies or designs or architecture. And then we build a table which says for HGV restrictions, what is the impact on this goal? -7%. What is the impact on this goal? Nothing. What's the impact on this goal? -56. Notice there's a whole series of negative things here. It does a little bit of good in clean air inhalation, but probably not enough to rescue this. And it does cost a fair penny, like 10% of the labor effort and 3% of the budget. So things like this probably should not survive just because they have a little bit of effect here. Here's a clean air route idea, not hurting anybody here, helping very nicely here, helping nicely here, here, here. Sum total on multiple objectives, 101%, and using 10% of the labor effort and 30% of the budget. Not bad. But looking at a third one, look at all these nice large contributions to all of our goals at, again, a cost not substantially different from the other one. So this is about 3 times better value for money, and we should prioritize strategies like this. So long story short, an impact estimation table, which what I'm showing you, estimation table, is a simple device, can do it on any spreadsheet or table, for looking at the multiple effects on your values and qualities, both for any set of strategies or architectures, before we select them, before we prioritize them, so we don't waste a lot of time on something that's going to cost too much and give too little. In addition, the same table can be used for building up incrementally the actual contributions step by step and the actual costs step by step. So it's used in 2 modes. Some of my friends think that this impact estimation table is the knees bees and will, solve all problems of analyzing everything in large complex systems. You can make up your own mind, but maybe try it out sometime. Let's see, we're looking at the idea of incomplete and out. Now I've got 12 minutes more, so I talk too much, but I can't resist trying to explain things in detail. So, but this is about completeness and things like that. You want some more detail. So here's something I also do. I'll tell you about it quite shortly. I start all projects by starting the first week. I call it a startup week, and this is how we work on the course, the BCS courses, and we quantify the top 10 critical objectives. Then we identify and quantify the strategies on day 2 and 3, and day 2, sorry. And on day 3, we quantify how good the strategies are for the and what they're going to cost, so that we have a multidimensional overview of how good the architecture looks to begin with. On the 4th day, we decomposed into small steps, usually a week, and try to find stuff we can do to start moving towards our goals incrementally, even in small increments, and getting feedback and learning. And then we can do some background planning and replanning of the big picture. But we're after about 1 week, we're in a do in practice and deliver value mode. Okay, so that's my startup planning week, and there somewhere there probably is a reference to detail on that. Principle number 5, small efficient steps. Okay. I think it's important to have an idea of how big a step should be. Now, in conventional Agile, people have homed in on my suggestion 1 or 2 weeks. So, and I'm still there. Another way of looking at it is getting down to certainly really no more than 10%. I actually like the number 2%. In other words, a step should be no more than 2% of the budget or 2% of the time to deadline. And what that does, it allows you to do a little pilot, in fact, before you scale up. And if it works very well, scale up, do more of it. But if it works badly, you can use the opportunity to change the strategies and maybe the method of implementation so it works better when you scale up. So this is about that startup week, and I don't have a lot of time to do much more with it. Principle number 6 related here. If ideas are going to fail, it's important that we fail fast. In other words, we plug them in early, we measure how well they're working and what they cost. If they fail us, we yank them out, and we've done no irrevocable steps like signing a 10-year contract, which we can't get out of, which would be pretty silly or something. And we fix things. We let the architect get in there and re-architect the architecture as IBM practiced in a very successful method known as the clean room method. Here's an example of a team. This is really a small team with one project, but they used all these ideas in practice with a simple spreadsheet, and they attacked these 4 usability goals in a 12-week period. After 9 weeks, they had 50% of this goal and 100% of that one and 200% of that one. Nothing here. And so they need to use the remaining weeks to work on the goals that have not been achieved at all or partly. I call this a dynamic prioritization. That is, we decide what to prioritize our effort depending on how things have accumulated up to now in practice, rather than prioritizing things in advance with fixed weights, as in balanced scorecard and other methods. Those are kind of silly, good enough for Big Bang, but not good enough for Agile methods. Let's see. Yeah. So here we are, step by step, building up towards, and we can see right away that our target level here, we're likely to be approximately there. We're unlikely to just suddenly go up. Only COVID goes up that fast in that short a time. So we need to do, so we can see at this point, we need to do something. If we either reset expectations to something more like that, or accelerate money, time, people, or better architecture to actually make it to this on time. Principle number 7, 7 minutes left. What we're trying to do with these methods is to get even in the largest of systems, get a result flow going quickly, like this month, not 8 years from now, as the Norwegian example with Axon. And keep the flow going, for better or worse, with our best guesses of what is smart, and then learn. The winner is the one who learns the fastest, says every historical case study of everything. So, in other words, the one who is most agile. So we need to get a result flow going. We need to compare and measure the effectiveness in the values and the costs compared to our estimated expectations. And when there's deviation from what we were expecting, we're not going to react 3 months from now or 8 years from now. We're going to react this week on behalf of next week. We're going to have an architect in the loop to do it. Or put another way, if you have step by step every week, and how many weeks will go by before you take action and change your architecture and other things? 3 weeks, 5 weeks. We're back to Einstein's principle that repeating the same idea and expecting to get a different result is definition of, what is it, being an idiot or something like that. But we do that. Here is the same team with the same real example of where they were after 9 weeks. And the thing you can see here is that they've used 75% of their time, and they're pretty much succeeding in many areas, but they have a few areas they've not succeeded in. So that's where they need to put their effort. That's why the spreadsheet has been programmed to automatically put up a red flag saying, this is where you need to work. You don't need to work there. It's at 100% of the goals, things like that. So in other words, we can give automatic feedback about where should you deploy or redeploy your effort. It's when you're on a roll and things are successful, it's tempting to go beyond what is asked for, but then you're starving the things that aren't fed of resources to get them done on time. So these gangs consistently, quarter after quarter, year after year, deliver very high quality results on target or better than target, usually. And there's a nice little case study of them doing it there. Okay, so number 8. Well, 4 minutes left. Here's an example of using the impact estimation table to look at values and risks and costs. This particular one was used by one of my friends on the energy analysis for Brexit by the Energy Department. But so these are a little bit doctored, so we're not giving away any secrets, but they really did, and the department really liked the idea that a one-page overview is fantastic. All this complexity on a single page. So that's, in a sense, a way of simplifying a very, very complex system. No matter how big it is, how complex it is, you should be able to deal with the critical factors, the critical costs, and the critical strategies, all with one overview and some summation of how things are working. And the impact estimation table gives you that capability. This is from the same gang, different view of energy for Brexit. I think Brexit's going to happen any second, right? So 2 more principles and 2 more minutes. Again, there's in large systems, there's a whole chain from the smallest detail to the largest, business failing or Brexit failing or something like that. And so you really need to understand the connection between all of these, and that's what this slide is about. We have to have traceability and connectivity and understand cause and effect. And tables like this help you look at least 2 levels of cause and effect and keep track of them. So that's the main point there. We have to keep track of things. And what I find is things in splendid isolation floating around all the time, as in the NHS things. There's really no organization there, and so we're bound to get lost, and we're bound to lose the kingdom for want of a nail. Here's another example, very large US government bank, and there's detail about how they had problems with the balanced scorecard and how we fixed it using these methods, and how they used the, in fact, the impact estimation table to help the US economy. There's more from the same case study of the specification of the critical objectives for a government bank. So, and only 1 minute and 1 principle left. I believe that for large-scale systems, we can no longer use PowerPoint slides or even simple spreadsheets. We need to digitize everything, all the requirements, all the relationships, all the assumptions, all the risks. Every little detail needs to be digitized, and so that digital systems can help us keep track of the enormous quantity of complexity that we are necessarily facing when we're doing large-scale agility. So we have a tool called ValPlan, which does it. We've lived for a long time on spreadsheets, but we have ValPlan, and we're developing other tools, and anybody is welcome. I think some Polish friends of ours are developing tools, but we really need to use IT to help us with the planning. Our manual methods that were good enough for the past are, in my view, no longer good enough at all for keeping track of the complexity. And these slides are just about keeping track of the complexity automatically. And so here's the talk summary, and going 1 or 2 minutes over isn't going to kill anybody, is it? But basically, we need to go towards systems engineering to tackle large-scale enterprises and systems. We need to quantify, measure, and clarify the stakeholder values. Okay. I have a book which summarizes the details, 100 tools here. Okay. This is a free copy of an otherwise charged book, so get it while you can. Here are more books, some of which you have to pay for, some of which are free. So if you're not feeling very rich, get the free books, but please read them. And if you want to pay a small sum for a book, pay 14 euros for saving your projects, might even be worth it. A little bit about what I am in the Agile area. And here is a recognition that my methods, which are still in use all the time and still considered superior to most of the Agile methods, were the roots or framework for a lot of the variations out there. So, and here, the slide we decided to land on is if you want to complain instantly, call my mobile phone, or even better, email me, and I promise to answer questions and supply you with information if you email me. No charge at all, part of the BCS service, right? I'm done. Only 2 minutes over. And
Tom, on behalf of all of the 3 SGs, I'd like to thank you very much for such a fantastic presentation, which we think was absolutely inspiring, and even though there's a lot to cover, and well worth a second follow-up. I think there might be some questions pass across.
I haven't seen any questions come up actually, Margaret, but I did have one of my own, if I may. Tom,
by the way, before anything happens, can I get my live picture up here if I get rid of the slides?
I don't think so, no.
Okay, we'll give it up. Please go ahead. Yeah, Tom, great talk, and thanks for that. I guess one of the questions I have, and I'm sure others on the call also have, is you talked a lot about large organization and complex programs. How far or what variant of your methodology would apply to maybe smaller scale projects and programs rather than the banks of various countries or large multinationals?
Now, the Confirm-It example I gave you is small in the sense that there was an 80-person organization worldwide and 16 developers. Now, that's small by many standards, right? And these methods work excellently there in helping them compete on the international market very successfully and grow their company and make it profitable. So now you get to a point where some guy is going to whip up a website for a friend this week. I don't think you need my methods at all. Okay. Now, the moment you're at National Health Service or Ministry of Defense or a large multinational private corporation that I was working with today, then you're big enough to need these methods very much. And one of the signs that you need these better methods is that you are failing to deliver what people are expecting, and they're talking about it in the press, in the government, and at the boardroom level. That's the short answer.
Right. Okay, thank you.
But this particular lecture, sorry, I should point out, this particular lecture is especially for large-scale enterprises. I'm not trying to say anything about these methods for smaller systems, although I accidentally did when I mentioned confirm it.
Yeah. Okay. Thanks very much. I guess I was really interested to see whether you could sort of scale down, as it were, the method to cater for smaller organizations.
Right. So let me give you. I have a set of slides and papers called about scale freeness of these methods. You could possibly find them in the references in the back, and I'm not going to try. You could possibly Google them, Gilb scale free. And if you're interested and you can't find it, email me. I will send you everything about what we found is not that the methods scale up and scale down. Intel declared after decades of experience, we know they work at any scale. We have large and small. Okay, so these methods are by design and in detail scale free. That is, they'll work on very small projects too. By the way, I have a thing called life design, and I have a little booklet on that, which you can probably get either by looking in the references or asking me. Now, life design is you, one person, designing your family life or your career. Okay. Now, that's a pretty small scale project compared to 10,000 employees, right? I use exactly these same methods for life design. So if you want to see the small scale use in your own personal life of these methods, get a hold of the life design book.
Great. That sounds great. Thanks.
And if you can't get it any other way, write me and you'll get it. But I think you'll find it floating around the references.
Okay, great. Well, I think Sohair and Margaret, I don't think there are any more questions.
Oh, great. In which case, if there's nobody else that would like to ask questions, I think very much we'd like to thank you so much for that brilliant presentation. And we're thinking of you over in Norway at the moment. Can I just actually ask a totally different question? What's the weather like?
Sunshine this morning and rain and clouds the afternoon. Depressing, as it usually is in November in Norway.
Well, we'll have the sunshine, because certainly down our on the south coast, it's been sort of wet and windy all day. So
if you have good weather, we get it the next day.
We might do. It's wonderful to have presentations. It's wonderful you can present from Norway for us. So thank you so much. And I think, we sort of all like to sort of say thank you so much, and we appreciate it. We'll actually stop the broadcast now. Thank you.
Thank you all for.
We close down.